This is Robert Smith from M2 Technologies, here to present you with a tech tip. In this video, we will briefly discuss the benefits of leveraging symmetry in your simulation models. We will also show you how to set up a symmetric model in Autodesk Simulation Mechanical. Finding the right balance between mesh complexity and the accuracy of results is a common challenge in simulation. Removing solid geometry from the problem reduces the amount of elements that need to be created. This can reduce solve times, or the extra resources you have gained can be spent on a finer mesh without increasing solve times. There are many ways to reduce the complexity of the geometry. This is also known as simplification. You can suppress parts from an assembly, suppress features from parts, or replace parts with less complicated approximations of themselves. Often 3D models can be replaced by 2D models. We will cover this in another video. If the geometry is symmetric across one or more planes of symmetry, or is close enough to symmetric that a safe assumption can be made, you can trim the model at the plane of symmetry, removing half, 3/4, or even 7/8 of the geometry from the model. Keep in mind that in addition to geometric symmetry, you must also be able to assume that all loading and reactions are symmetric across the same plane. If your assumptions about symmetry are sound, and you have taken the following steps to constrain it properly, the difference in results between a symmetric model and the full version should be negligible. For the most part, setting up and running a symmetric model is no different from setting up the full version. There are some key boundary conditions that must be applied to get the proper behavior from your sectioned model. Let's take a look at an example model, with the full version and the quarter version run side by side for comparison. First, let's do it the wrong way. We'll apply the same constraints and boundary conditions to both models. You can see clearly in the results that the quarter model is not reacting as the full version reacts. Let's go back and see what we need to add. Using the general constraint command, we will apply symmetry boundary conditions. There are preset buttons in this dialog, which will fix the correct degrees of freedom to give us the behavior we expect. These boundary conditions must be applied to any surface that touches the imaginary plane of symmetry. Whatever global axis is normal to that surface is the axis you will choose from the symmetry presets. Different axes must be applied in separate boundary conditions. You can see now the results are nearly identical. The symmetry boundary conditions will prevent the model from translating across or rotating through the plane of symmetry, emulating the material that's on the other side of the plane. The model is free to slide along the plane of symmetry, but not separate from it or pass through it. Mirror planes can be activated to visually restore the removed material, giving the appearance of the full model. Look for another video discussing the stability benefits of using a symmetric model. Thank you for your time.